Write down the first four terms of the binomial expansion in ascending powers of x of 1 plus ax to the power n, where n is greater than 2. So we'll start off with nc0, 1 to the power n, ax to the power 0. Our second term will be nc1, 1 to the power n minus 1, ax to the power 1. Then nc2, 1 to the power n minus 2, ax squared. And then nc3, 1 to the power n minus 3, ax cubed. Those are my first four terms. I'm going to simplify each of those. nc0 I know is 1, 1 to the power n is 1, and ax to the power 0 is 1. nc1, I know that is always n. 1 to the power anything is going to be 1, and ax to the power 1 is just ax. nc2, sometimes I forget what that is, so I'm just going to use the NCR formula to help me out here. So I know the NCR formula is n factorial over n minus r factorial times r factorial. So therefore, nc2 would be n factorial over n minus 2 factorial times 2 factorial. Which, when I write down what that means, n factorial means n times n minus 1 times n minus 2 times n minus 3 and so on. N minus 2 factorial means n minus 2 times n minus 3 and so on. And 2 factorial means 2 times 1, which is 2. We then have a series of terms that cancel out. And so I just get left with n times n minus 1 over 2. That is my expression for nc2. And that's multiplied by 1 to the power n minus 2 and a squared x squared. We then have nc3. And again, I can't quite remember what that is off the top of my head, so I am going to, again, use the NCR formula to help me out with that. So let's come back down to the bottom. nc3. n factorial over n minus 3 factorial times 3 factorial. So n times n minus 1 times n minus 2 times n minus 3 and so on. Over n minus 3 times n minus 4 times n minus 5 and so on. And then the 3 factorial is 3 times 2 times 1, which is 6. We can see the n minus 3s would cancel out, the n minus 4s would cancel out, and so on. And so I just get left with n times n minus 1 times n minus 2 over 6. This is my expression for nc3. One to the power n minus 3 is 1. And then we have an a cubed x cubed. Right, let's now simplify each of those terms. Just clearing a bit of space down here for part B of the question that we'll get to in a moment. Right, okay, simplifying each of those terms. 1 times 1 times 1 is 1. N times 1 times ax is nax. Then we have n times n minus 1 over 2a squared x squared. And n times n minus 1 times n minus 2 over 6 times a cubed x cubed. So those are my first four terms of that expansion for part A. Given that, In this expansion, the coefficient of x, so this is my coefficient of x, is 8. And the coefficient of x squared, this is my coefficient of x squared, is 30. So I'm told that NA equals 8 and n times n minus 1 over 2 times a squared is equal to 30. I need to calculate the value of n and a. So this is simultaneous equations that I need to be solving here. So first thing I'm going to do is I'm going to multiply both sides of this equation here by 2 just to try and make this a little bit simpler to get rid of that fraction. I'm then going to make a the subject here. So rearranging that to be a equals 8 over n, so that I can take this and substitute it in here. So I'll get n times n minus 1 times 8 over n all squared equals 60. So n times n minus 1 times 64 over n squared equals 60. Times both sides by n squared to get rid of that fraction. Let me expand out these brackets now. So I've got n times 64. And then the n times minus 1 times 64. I'm going to move the n squareds all over to one side. So I get 4n squared minus 64n equals 0. I'm going to factorise. So I can take a 4n outside. And so I can say therefore n equals 0 or n equals 16. I know n can't equal 0 because I was told that it had to be bigger than 2. It wouldn't make any sense in this question if the power was 0 at the beginning. So I can eliminate n being 0 and focus on n being 16. And if n is 16, then a is 8 over 16 or 1/2.